Do I have to do something? Okay. Thank you, Professor Chang, and thank you for organizing committee to invite me here. And I'm going to talk about impact of indoor environmental quality on personal exposure today. And first slide. Probably some of your reaction will be, oh, no gain. You saw this kind of model so many times this week throughout this conference. But the reason we try to look at this model is to understand and to predict what is going on in indoor environment. And some of these components include ventilation, and actually the previous speaker was talking about ventilation, and source, and control measures, buildings, and outdoor levels. All of these factors will influence this indoor environmental quality. So that's why I think this week so many scientists get together here and try to understand this issue. My talk is going to a little bit expand this aspect. Okay. So in this box, we assume this is an indoor environment. And we try to minimize this air pollutant inside this box through various factors. But as Professor Young was talking about, one of the components is people. And the reason we try to minimize this air pollutant in this box is to protect the human being, protect the comfort, protect the health effect. And in order to make that happen, that the health effect can occur, then we need to have a personal exposure. So some of you already know what is a personal exposure, but I want to describe with a picture. So this right now, this person's exposure is 0, assuming that outside of this box, there's no air pollutant. But once this person go in, personal exposure is high, personal exposure is none, personal exposure is high, it's none. I think we have to stop here one more time. Okay? So this kind of concept is very important because even if we have a concentration inside box, if that person is not get into this space, then personal exposure will be very low. So through this kind of concept, we can actually explain how important this indoor environment is. So personal exposure can be described by indoor concentration and residential time. So in previous slide, I showed the concentration is located in inside box, and then person, it was a stay outside. In that case, personal exposure is none. But if that person go inside the box, then their personal exposure will go up. So from previous researches, then we know that many hazardous chemicals, especially organic compound, concentration indoor is higher than outdoor. Some of these ratio can be more than 1 and more than 2, or sometimes more than 10. And most of us here already know that indoor environment is very important because we stay indoor about 90% of our lifetime. Especially those of you here studying over the lifetime, I think you probably stay longer, even longer than a general public. So just ratio of residential time indoor will be 9 times more than outdoor time that we stay. So we just simply put this number into this equation. Then we know the personal exposure from indoor space will be 18 to 180 times more than exposure from outdoor space. That's why I think we're here. That's why we spend a whole week to understand this indoor environment. So I think in this conference, many of us is trying to protect people from this exposure, and we already know that most of exposure is coming from indoor space. So I think in history, we are pretty good at measuring indoor concentration. About 20, 30 years ago, some of these measurements, the unit was like ppm. Now, the instrument we have right now is sometimes can go to ppt, not even ppb. So we are very good at measuring this microenvironmental concentration now. It's getting better, of course. But one other component is residential time. So in order to protect people from exposure, we need to get this kind of information. I think we are a little bit behind on this exposure time information. So today I'm going to explain how to get into this residential or exposure time. So we are here, this person again show up, and throughout our lifetime, we go to many other places. Sometimes go to home, I think it's the home, and friends' home, shopping, library, all this. And depends on where they're going and how long they stay, which microenvironment. Their exposure will be different for pollutants, and their exposure level will be different. And to understand this movement and the exposure time will actually dictate how much we expose to certain pollutants. And as you can see, depending on microenvironment, we have a different pollutants. That's what we're trying to figure it out. That's why we go to field and do measure and to identify these pollutants, and also do a lot of chemical reaction studies. So for going back to personal exposure, individual exposure is pretty simple. So if the person go into space, indoor space, then exposure go up, and once they come out, the exposure will be lower. But the problem is we are more interested in population, not just one person. So if we have so many people here, then that kind of understanding can be very complicated. I'll show you this. I just look at the 10 people here, 10 person here. And some of them go into the indoor space and stay there. Some of them never go into that space. So we have to look at this population and how to characterize this population exposure is one of the issue. For one person, we can actually measure one person, but in a huge society like Hong Kong or the Seoul that I came from, we have 10 million people in one city. In order to characterize this large population, then we need a 10 million monitor to do this, or we have to do some other way. So that's what I'm trying to talk about today. So when you look at this impact of indoor concentration on population exposure, probably there's two questions that I can talk about today. Is which indoor environments are significant for population exposure? And then how to assess. And then hopefully we can identify the source of this pollutant and to manage those sources. So 1996, that's the first, I think that's a paper came out. Even the study was conducted before. That's like 20 years ago. And the P-team study was published. And then at that time, we were using this time integrated monitor. And then compare personal exposure data with the indoor data and outdoor data. And somehow, personal exposure measurement was higher than the indoor and outdoor integrated exposure. So I think at that time, we named that kind of a phenomenon as a personal cloud. Okay. And then, of course, that personal cloud, right now, we know that it is associated with personal activity. And also, indoor particle, more than half of the indoor particle is coming from outdoor. Okay. But we still, at that time, they didn't know what other sources are in indoor. And just strictly comparing personal exposure with outdoor ambient monitoring data, and the correlation was not that good. So that's why trying to understand how to explain this personal exposure in a population. And as this conference, Professor Nazarov also presented very interesting aspect that personal presence was very important for a bioaerosol. I think there are lots of sessions on bioaerosol, and it was not just about environment, that we have somehow connection with the personal presence with a microenvironmental concentration. So to explain this, there some other approach came up. One is a shared model, and that's a modeling. It was a probabilistic model to estimate population distribution of total PM10 exposure, PM2.5 exposure by randomly sampling from various input distribution. So this kind of model require many measurements in various environments, and then they put together with the personal behavior to understand the concentration of population exposure, and also contribution from various sources. And their conclusion was ambient PM2.5 eventually contribute significant percentage of total PM2.5 concentration through the presence of outdoor and also the infiltration from outdoor to indoor. Now, so of course we know instead of modeling, the direct monitoring is what we prefer, and always give us a better information. The problem of population exposure monitoring is that a number of monitoring subjects is very limited. And if we want to representative sampling data from Hong Kong or Seoul, it's several million people is living in one city. But we don't have a resource. So in many cases, study is a limited, very specific group. And also, personal device is limited. And nowadays, we are getting more and more devices coming out, portable and continuous real-time monitor. But still, in terms of pollutant, it's limited. So I actually come up with a different approach. It's, instead of recruiting 1,000 people from one city, we try to simulate this personal and population exposure. The simulation was based on activity pattern of actual population. And I'll show you that somehow when we analyze this activity pattern of Korean population, we were able to explain by 9 or 10 group. So based on that activity pattern, that we carry this continuous monitor for over 24 hours, repeated this the activity, and those kind of data was able to explain the population exposure. So this is a Korean activity pattern collected by Korean government, not for environmental purpose. This is actually for economic purpose. So every 5 years, Korean government is collecting over 30,000 people's activity like this. So we know during the weekend and weekday, there are different patterns. And because of their purpose is not for exposure, they have only two components. One is indoor, another one is transportation. But we can assume, other than this, will be other spaces. And then I analyzed this 30,000 persons' data, and I found about 9 or 10 group can explain over 96% of population. And some of this is shown here, and I show you there are 3 types of office workers. This one is actually, they basically stay in this office for their working time. And these people sort of has a little bit different pattern, but you can see for this group, in order to go home, over the 50% of this population go home, that's about 10, but in here is about 6. So they have a different pattern, even though they have the same kind of occupation. And another very interesting aspect is who is supposed to be stay home most of the time. That's one group is a homemaker, female in case of Korea, and then elderly. So they have a similar pattern, but clearly there are differences in the morning. So this elderly is getting exercise in the morning. They go to mountain in the morning, so you can see the peak that they're going out very early in the morning, 6 a.m. Another group is high school student. So you can see most of these high school students get out of home, and then they go home. A certain percentage of these students go home after the school hour. So this population actually going somewhere to study after school. So as you can see from this activity pattern, there are very clear characteristics, and those 9 to 10 group can explain over 95% of entire population. So the outcome from this actually was we analyzed by the city. So different cities has also very similar pattern. And of course, city and rural population were different. And we have a 2 cycle of data. They collected this information over 5 years, every 5 years. And then when I compare these characteristics of this group, the urban group, they are very similar over the 5 years. Rural, they stay very similar. So from this outcome, I assume that this simulating this activity pattern can simulate the urban and rural population exposure. So this is the data from the Seoul, and I want to emphasize this group 3 and group 4, group 9. Okay, and both of them are office workers. But one group stay someplace other than home after 6. Group 9, they go home after 6. Okay, so those are the difference between these 2 groups. And when we simulate simulate this activity and carrying this PM 2.5 monitor, and their exposure is a 4 times difference. Group 3 is about 43 microgram per cubic meter, and group 9 is about 10. They are having similar office environment, but just staying somewhere else after 6 actually causing so much big difference. So where this the exposure is coming from, which microenvironment is actually causing this 4 times more population exposure. So it turned out that when the office worker finish their working hour, they go to restaurant and bar, and that's where they have such a high exposure. So you can see in restaurant, it can go up to close to 200 microgram per cubic meter. And in the bar, it's about 70. But if they go home, then the exposure will be only about 13. So those place, microenvironment, is actually causing huge difference in population exposure. So when you look at the time and concentration, the contribution from this restaurant and bar will be very significant in Seoul population. I think when I compare with Western data, the contribution from residential indoor is very significantly lower because of this high concentration in some other places. So what's going on in that restaurant? So we visited many places in Korea, and it turned out that some of you, if you come to Korea, we like a barbecue. It's cooking in the table. So we're using charcoal. Once you charcoal, the concentration can be very high. Okay? And also, some of these places allow smoking. So those two factors can influence this population exposure in Seoul. So from this simulated monitoring, we identify microenvironment which significant to personal population exposure, and also we identified the source where this PM 2.5 is coming from. So once we know the source, then we can actually control by applying this smoking ban, and also changing cooking behavior. Well, I talked to a city council member in Seoul government, and they said, no, you cannot change cooking behavior. Of course, if researchers said, do not have a barbecue because of PM 2.5 exposure, then they're not going to change their behavior. But we can actually change the ventilation system in this kind of setting to minimize emission to the indoor environment. So this kind of simulated monitoring will allow us to identify significant microenvironment and also allow to detect the source of this high exposure. Okay, the next one is that when we go to somewhere in indoor environment, people is not just sitting. Yeah, in your case, you're sitting, but most cases, we do something. That behavior is also causing this exposure. So I'm gonna, second part, I'm going to talk about this human behavior impact on personal exposure. So human behavior, just being in here, we can have higher exposure. That is explained by personal cloud. And throughout this conference, there are many studies showing certain activities like cleaning can increase PM 2.5 exposure or PM 10 exposure. But I'm going to talk about today, focus on consumer product in this part. Consumer product. When we went to a supermarket, you will see many, many products, different products. And I remember about 25 years ago when I went to US first time, in the supermarket, only one aisle of a consumer product. Now, several aisles by the purpose, very specific purpose. That means we are using many, many different consumer products. And consumer product is including chemical. That sometimes we know what it is, sometimes we don't know. So, I think consumer product is getting, I think, it's very important for indoor environment because they are using more chemical. Sometimes we don't know toxic information, okay? And they're developing this new product with a different purpose, and we can actually expose to a different route. And of course, they are making more because we are using more. So where are we using? Usually in indoor space, okay? So by having so much chemical in that product and by using more, used by more people, then we have a potential to have a higher exposure from this kind of product. And another concern that I have is that they tend to have a multifunction. So especially they said there is cleaning, including air freshener. That means they are cleaning and then they provide this fresh smell. So therefore, people tend to close the window. So that kind of multifunction may cause higher indoor concentration. In fact, several years ago in Korea, we had this strategy of humidifier cleaning solution problem. Humidifier is sometimes very good to increase humidity, but if we don't clean up, microbial contamination can occur. So this company decided, oh, we can provide antimicrobial solution. So as selling this product to people, population, and then these people will put this solution inside this humidifier and then operate. What happened is when they have this kind of chemical inside, that actually increase airborne concentration. And then this chemical actually used in the wet towel. If you go to some of these restaurants, they give you wet towel. And that has antimicrobial function. And then this chemical is inside and become airborne. And then we have actually over confirmed cases about 50, 60. But we have cases over 150 death case in Korea. So right now there's a lot of discussion on how to handle this. Of course, we don't sell this anymore. But this is one of the examples, the consumer product, just to make us comfortable. Instead of cleaning this humidifier, we put this chemical. Okay? So this kind of new product may show up. Okay? And according to the company, these chemicals has a toxic effect on dermal absorption only, no inhalation toxicity. So that's why they use this kind of chemical.
1 minute.
Okay, and then we also use lots of air freshener, but we know there's a lot of chemical inside. Okay? So instead of actually solving source of problem, we're just masking by spraying this kind of chemical. Do we spray just a little bit? No, we have to mask it, so we have to keep spraying this kind of chemical. And that is causing potential problem to environment. And also we know that through the indoor chemistry, the secondary air pollutant can be generated, not just the chemical inside. So we have to know all this, and those kind of information actually is going to create indoor environmental problem. So we are measuring these chemicals, but today I'm going to talk about this exposure factors. How much chemical inside this product is important. What kind of toxic chemical they're using is important. But how much they're using is also dictating this indoor level and therefore risk level. And those information on exposure factor actually is very limited. So a couple of years ago, I conducted this exposure factor assessment, and we tried to collect data from representing Korean population, over 3,000 people. And we had to use questionnaire, and we did this measurement. And it was a pretty new approach, and then we limited to this kind of product. And the problem I actually occurred to me was how to measure amount of use. We have to use a questionnaire, so quantification was very difficult. So we ask a number pumping, and then we weigh the product. That was relatively easy, but for tube type was difficult. So we created this circle and put in the card, and then we weigh this product weight. And the most difficult part was a liquid type. Okay, and so in this case, we tried a couple of different measures, and we decided to use a soju glass. Soju is one of the liquor that I think most Korean is drinking, and turn out their size is standardized. So if we use this soju glass, then people recognize, oh, I'm using about one full of this glass. Then we know, we can quantify this solution. And also, this questionnaire was collected from 2,500 households, but we visited small number to confirm that questionnaire information was accurate. So I'm using just one very common consumer product, shampoo. Turn out, Korean is using more shampoo than European, but American is using more shampoo than Korean. Okay? So those kind of information was collected through, can be collected through this study. And after that, right now, we have a copper project that for 3 years, that we are actually analyzing the chemical inside and then also determine this indoor exposure level through this, the modeling that using exposure factors. And eventually, we are going to characterize the risk of using this kind of product. Okay, and this study was one of the biggest R&D projects funded by Korean government on the environmental issue. And I think since we just studying this, we don't have data, but I think in the environment scientists, we should thinking about this kind of issues. So conclusion, indoor environmental quality is very important for public health. And there are significant microenvironmental exposure that influence the personal exposure. And then we can identify source when we identify this microenvironment. Of course, identification of source will lead to management of source. And also, we have to now thinking about influence of personal behavior on indoor environment. And I introduced a consumer product as a potential source on this indoor air. And I'd like to suggest a few things. First, I think you hear many, many times that human is not just a receptor of this indoor environmental problem, but we can be a potential source. So we need to think about where people are, what they're doing. Actually, those kind of factors will influence indoor air quality issues. And I think also because a human is influencing this indoor environmental quality, that we need to detect human behavior and human movement. If we can do that, then we can probably provide a dynamic indoor air quality management. And recently I'm working on this field in which I found this very limited technologies available here. So the best human movement measurement technology is clicking this counter. But that's not going to fly to this modern society. So we need to develop this new technology to provide this better management. And also, I like to propose that we need more portable devices that can provide better data. And one of these solutions, one of the tool will be the mobile phone. So we have to look at this tool to provide this more accurate data on this indoor environment and population exposure. So with that, thank you for your attention.
Thank you very much, Professor Lee. I think those four talks covered lots of things, but to me, two take-home messages. One is that there's lots of sources in the home, in the offices, in airplane cabins, and then there are people. People really made the whole exposure situation more complex. And I think, beyond this session, there will be actually people's health that's not incorporated here, but it's already very complex. I find it's fascinating research that being conducted in various labs here. And I wish I have more time to interact with our speakers. You can certainly try to catch them at the break. And thank you all for your interest, for staying through the session. Let's thank our speakers for one more time for giving us very interesting lectures. Enjoy your lunch.